Hello and welcome to our video on black holes and wormholes. In this video, we'll be exploring the mysteries and possibilities of two of the most fascinating objects in the universe. Let's start with black holes. Black holes are regions of space-time where the gravitational pull is so strong that nothing, not even light, can escape. The idea of black holes was first proposed by the great physicist Albert Einstein in 1916, but it wasn't until decades later that they were discovered and studied in detail. Black holes come in different sizes, from small ones that form when stars collapse to massive ones at the centers of galaxies that are billions of times the mass of the Sun. When matter falls into a black hole, it is compressed into an infinitely small point at the center of the black hole called the singularity. One of the most fascinating things about black holes is that they warp space and time around them. This effect, known as gravitational lensing, can cause light to bend and distort as it passes near a black hole. It also means that if you were to get too close to a black hole, time would appear to slow down and eventually stop altogether. Another interesting property of black holes is that they emit a type of radiation called Hawking radiation. This radiation is named after the physicist Stephen Hawking, who first proposed its existence. Hawking radiation is thought to be caused by the quantum effects that occur near the event horizon of a black hole. Despite their mysterious and awe-inspiring nature, black holes are not all-powerful. They can eventually evaporate due to the emission of Hawking radiation, although this process takes an incredibly long time for large black holes. Now let's move on to wormholes. Wormholes are theoretical objects that are thought to be shortcuts through space and time. In other words, they are a way to travel faster than the speed of light without violating the laws of physics. The idea of wormholes was first proposed by the physicist John Wheeler in the 1950s. Wheeler suggested that space-time could be thought of as a fabric that could be warped and bent. He also suggested that two distant points in space-time could be connected by a tunnel-like structure, which he called a wormhole. Wormholes are thought to be extremely rare, and their existence has never been confirmed. However, if they do exist, they could have some fascinating implications for space travel and exploration. One of the most intriguing possibilities is that wormholes could be used as a shortcut between two distant points in space. This could potentially allow humans to travel to other stars and galaxies without the need for long and dangerous journeys through space. Another possibility is that wormholes could be used to travel through time. This idea is based on the theory of relativity, which suggests that time is relative and can be affected by gravity. If a wormhole could be created that connected two points in space-time with different gravitational potentials, it could theoretically allow for time travel. However, there are many challenges and obstacles to creating and using wormholes. For example, they would require enormous amounts of energy to create and stabilize. They would also need to be carefully controlled to prevent dangerous and unpredictable effects on space and time. Wormholes are purely hypothetical. Wormholes are theoretical objects that have not been observed or confirmed to exist in the universe. They are based on mathematical models and are subject to ongoing research and investigation. Wormholes are a prediction of general relativity. The idea of wormholes was first proposed by physicist Albert Einstein in his theory of general relativity. The theory predicts that wormholes could exist as a consequence of the curvature of space-time. Wormholes could provide a shortcut through space-time. If wormholes were to exist, they could potentially provide a shortcut through space-time, allowing for faster-than-light travel or communication. Wormholes could have a throat connecting two points in space. According to theoretical models, a wormhole would consist of a throat connecting two points in space-time. The throat would be surrounded by an event horizon, beyond which the gravitational pull of the wormhole would be too strong for anything to escape. Conclusion. In conclusion, black holes and wormholes are two of the most fascinating and mysterious objects in the universe. While we still have much to learn about them, they have already inspired generations of scientists and science fiction writers alike. From the warping of space and time around black holes to the potential for faster-than-light travel through wormholes, these objects continue to captivate and inspire our imaginations.